Hello, so continuing on Leetcode contest, weekly contest 168. This is the last problem, maximum candies you can get from boxes. Problem number 1298. So the problem says we have n boxes and each box is given in the format status, candies, keys, and contained boxes, such that status at position I contains an integer where if the value is 1, that means the box is open, and when the value is 0, the box is closed. And so basically we have boxes that have candies, and these boxes can be opened or closed, and we have the keys for the boxes, and we have, because some boxes are closed, we can find some keys in boxes that can open these boxes, and also some boxes contain other boxes, and we also get an array of initial boxes where those, if they are open, we can take the candies right away. So we will start with these initial boxes, and we can take all the candies in any open box, and if the box contains some keys, we can use these keys to open new boxes, and you can also use the box you find in a box. So basically, if let's say you have a set of boxes, you can only take, even if other ones are open, you can only take those that are in the initial boxes, and then from the initial boxes you can access more boxes or access more keys to open boxes that are inside the initial boxes that you got, right? So it will be more clear maybe with an example. So let's say here we have the statuses of some boxes. The first box is closed, is open, so 1. The second one here is closed, this one is open, and this one is closed. And these are the number of candies in each of these boxes. So the box at index 0, which is open, has 7 candies in it. The one at position 1 that is closed has 5, so if we open it we get 5 candies. And these are the keys in each box. So the box at index 0 has 0 keys in it. At index 1 has 0 keys in it, but the box at index 2 has the key for the box at index 1, right? So the content of keys represents the box position, right? And contained boxes are here. The box in position 0, which is open, contains 2 other boxes, which are the box at position 1 and the box at position 2. And the box at position 3, 0, 1, 2, 3, which is the last one that is closed, the box at position 1, which is the one here that is closed, contains the last box, which is closed here. And initially we get only one box, which is the box at position 0 that is open. So we get that one, and so what we can do is, while we get the first box, this box at position 0, we'll find 7 candies in it, so we will keep that. We'll keep that here, and then we'll find in it the boxes at position 1 and 2. The box at position 1 is closed, so we can't use it, but the box at position 2 is open, so we can. And so we take the 4 candies in it, so now we have 7 and 4. And then the box at position 0 has no keys, but then since we opened box at position since we got the box at position 2, because it was in box at position 1 and it is opened, then from there we get, so 0, 1, 2, we get the key for box in position 1, right? And since we already obtained box in position 1 in the first box that was open, we can now open it, because now we have the box and we have the key, so we can open it. And so we open the box at position 1 here and get the 5 candies that are in it, and that's it. The box at position 3, we get it when we open the box at position 2, but the problem is it's closed and we didn't get the key for it, right? And so we can't open it, so we can't get the candies in it, so overall we get 16 candies. So that's the idea. You can go over the other examples to understand it, but this is the main idea. So how can we, let's see how can we solve this problem. Okay, so let's see how we can solve this problem. So first, let's take the first example that we have there, which is that we have the following state for the boxes. So one is that the status is, the first one is open, the second one is closed, the one after that open, and then closed. And then we have candies, and for the candies, the first one contains 7, after that 5, 4, and 100. For the keys, we have the first one contains nothing, second one nothing, third one contains the key for the first the box at position 1. After that contains no keys. Contained boxes, so the first one contains the boxes 1 and 2, the second one contains box 3, the one after that is empty, it doesn't contain any boxes, and initially we get the box at position 0 only. And so if we can kind of draw this out just to get an intuition of what is happening here, so if we have, the box at position 0, right? So the positions are 0, 1, 2, 3. So if we draw out the box at position 0, let's say this one is the box at position 0. So that one has the following boxes. So it has the box 1 and 2, right? So it has the box 1 and has the box 2 in it, right? So these are like their position. Now the box at position 1 is open, so this one is open, that's why I left it like this. The box position 1 is closed, so this one is closed. And the box at position 2 is open. The box at position 3, which is actually in box 1, so this one contains box at position 3, and that one is closed, like this. So you get the idea of how this works. So I'm going to put in this color here. These, I will put the candies number or count. And so box 1 contains 7 candies, box 0 contains 7 candies, box 1 contains 5, 2 contains 4, and the third one contains 100. And then in each, I put the contained boxes. Now let's put the keys. So I will put in, let's say, this here, I'll put the keys. So in position 0, 1, 2, position 2, so the box at position 2 has key for box 1. So that here has key for position for this box here, right? And so now we need to have box 2 to be able to open box 1, and once we open box 1, we have box 3. Now we need a key for box 3 to be able to open it, but unfortunately we don't have the key for box 3, so we can't get the candies in there. So you could see here that there is a dependency between the boxes, right? So for example, in order to be able to get the candies in box 2, we need to have box 0, which unfortunately we have that in the initial boxes, so that means we can get it. In order to be able to also get the candies in box 1, we need to get box 0, right? And get the key to box 1. And to get the key to box 1, we need to have box 2, which fortunately we have it in box 0. So you get the idea of the dependency. So basically, box 0 gives us access to box 2, right? And gives us access to, so this is just access, not necessarily the candies in it, because that depends on whether it's opened or not, or whether we have the keys or not. Box 0 gives us also access to box 1, right? And box 0 gives us access to key 1, right? Key 1, right? So you can see here with these dependencies, you need one box in order to access that box. To access the next box, then we need to think immediately of using BFS, and we could just simulate using the data we have, and BFS basically adding by adding to BFS queue only boxes that are that are available, which means we have them, we have access to them, and are either open or we have keys. We have the key, right? And so we just need to orchestrate our BFS in a way that we can process this here. And so how can we code this up? So one thing we know is that we need a queue so that we can put them, right? So once we find like a box is available and open, then we add it to the queue, right? So this is the process that we will do. One thing we need to be careful of is not to terminate, not to keep processing boxes indefinitely. So for that, we will need to have a visited or a done set that will keep track of boxes that from which candies have been collected, right? So that we don't recount them and we don't process them again. So boxes that have been processed, I'm just going to call it processed or handled. We also need to know the available boxes we have so that we can check if a box is available. So for that, we need to have available, which can be just a set. Same thing for visited, or it can be an array to keep track of boxes that we have. Why do we do that? Because sometimes, in some cases, we might have the box, but it's closed, right? And we might obtain the key afterwards, right? And so we need to keep track of the available box so that once we obtain the key, we can directly open it and use the candies in it, right? And we need our queue, right? Our queue that we will to put the boxes that are ready to be processed, right? Because they are both available and opened, right? And so this one here can be initialized to the initial boxes that we have, right? Same thing with the available, since it's available, and the visited, right? And so that's pretty much it. And every time we get a box from the queue, we will check the boxes that it contains, because those are now available. We will add them to the available data structures that we have, and then we will check if they are opened. If they are opened, we add them to the queue. If they are not, we don't add them to the queue. And then we will also check the keys in the box that we are processing. If we mark, so once we have the key, we can mark the box as opened right away. So once we get a key, then we mark the box as opened right away, right? Because now we just are waiting for it to be available and we can use it. And to do that, we can just do something like status for the box. We can set it to 1, right? And now, if that box is in the available set of boxes, that means we can start processing it and we can add it to the queue, right? And so that's what we will be doing. So now let's just initialize those data structures and see how this will look like. So first we need the available, so let's set definition. So it's max candies. And I'm just going to assume that we have the input here. And we need the available set, which gets initialized to the initial boxes that we have, right? So those we already have them, they are available, right? And we have the visited set that I'm just going to initialize to the initial boxes because I consider that that I'm going to process them. And then I need the queue that will contain all the boxes that are ready to be processed. And so this one also gets initialized with, so with BFS we use DQ in order to keep track of the things to process, and we add them to the end and we get them from the front, right? And so here we'll add the initial boxes, right? And now while we have something in the queue, we have something to process, we will continue, right? And so the first thing we do is we get a box out of the queue so that we can process it, right? So we get it from the front, right? And then the next step is, well, we need to return the final result, right? Which is just the candies that we obtained, the maximum candies that we obtained. Basically with this, we will get as much candies as we can. We won't stop until we can't get any more candies, and that way we'll get the max candies possible, right? And so here, as soon as we get a box, since it's in the queue, that means it's available and it's opened. So I can like take these initial boxes and check if they are opened, but I'm supposing that the initial boxes that we have will be opened already, and so I'm going to add them since I know anything in the queue is anything in the, I'm coding my solution here so that anything in the queue is available and opened, right? And so that means I can get the candies, and so I can just add them by getting candies in position of the box, right? After that, I will go through the boxes. So I have a box, so I have access to the boxes in it, and so I will look at the contained boxes so that I can get the boxes in there and check them. And so to do that, I will just say for the contained boxes, C in contained boxes of the box that I'm processing. And so if I get that, first I will check if I already processed it, because if I already did, I shouldn't even worry about it, right? So if that is in visited, I should stop. So I should just continue to the next contained box. Otherwise, I need to add it to the available box, because now it's available, I have it, right? So I will need to add to the available boxes, right? And then I will check if it's open, because if it's open, that means it's ready to be added to the queue. And so to do that, I'm just going to check if the status of the contained box is 1. That means it's ready to be processed, so I can add it to the queue. And I added it to the queue. That means I visited it in my simulation of the graph here. So I add it to the visited set, so that I don't visit it again next time, because it's already being queued to be processed. I don't want to queue it again, right? Okay, so now I handled the contained boxes, right? Now I need to handle the contained keys. And so for every key in the keys for the box, so key at index box, it gives me the keys that are in that box, the one that I marked here. And so for key in keys of the box, same thing. If that box, which I get by, let's just call this K. So if that is visited, I don't need to worry about it, right? So I can just skip it. Now otherwise, I need to check. So otherwise, I have the key now, so I know it's I can open it, so I can just consider it opened, and then I will just wait for it to be available if it's not yet available. And so once I get a key, I mark it as opened using this here. And so once I get a key, I'm going to mark it as open by doing status of the box equal to 1, right? And so now that I have it opened, I can check if it's already in the available set of boxes, because if it is, it was closed, so I didn't add it to the queue. But if I now have the key and I opened it and it's available, that means it's ready to be processed, so I add it to the queue. And so I do if k in available, right? So that means it's ready to be processed. So I do the same thing that I did here, which is add it to the queue and add it to the visited set so that I don't re-add it to the queue again, right? And that's pretty much it. Now, once I'm done and the queue is empty, that means I processed all the available and opened boxes. I can and got the candies from them, right? Because I would have popped them off and got the candies. I can just return the final result, right? And that's pretty much all there is to it. So the overall algorithm is just get the initial boxes, right? Those are the available boxes that I have, and start off processing those. And so they are opened, and then I check the boxes in them. If any of them is open, I add it to the queue to be processed. If something of these contained boxes is not open, I keep track of it, and then waiting for me to have the key so that I can open it. And then I process the keys that are in the box that I just got, and I check if I mark it as open since I have the keys for it. I check if it's in the available boxes that I have. If it is, that means it's ready to be processed, so I add it to the queue. And every time I pop from the queue, I add the candies that I got, and at the end I return those. And so this is pretty much it. Yeah, so let's type this in Leetcode and see if it passes. Okay, so I typed the solution that we just went over, and so it's the exact same one. We have the available, we initialize available, visited, and the queue, and we process them in the order in which the boxes are laid out. So the contained boxes, if they are opened, we process them, and if not, we keep track of them. And that's pretty much it. So here, and I collect the candies, and at the end I return the result. So let's run this and see if it passes. Okay, so it seems okay, so let's submit. Okay, so that passes. Now in terms of time complexity, so the queue here, we won't add more than the available, the entire set of the boxes that we have, right? And if we consider that to be n, then at most, since we have the visited here that prevents us from processing a box multiple times, that means we will do at most of n time here. Yeah, so that's pretty much it. In terms of space here, I have these 3 ones that will go up at most to n, so it's also of n space, I think. Yeah, so that's it pretty much for this problem. Thanks for watching, and see you next time.